All right, hi everybody, welcome to the Zero Touch Diagnostics Collection session brought to us by our friends at Salesforce, specifically Ryne Haley and Carlos de Jesus. Welcome to the stage, gentlemen.
Thank you.
Do we need chairs for these guys? Is it a sit-down thing or what?
Yeah, we can stand.
You guys are good?
We practice standing.
All right, you let me know.
I think we're good.
They have a routine.
Move around. We've been sitting a lot today, so awesome. Well, let's get this started. Like we were introduced today, we're going to be talking about Zero Touch Diagnostics Collection. And so first of all, thank you so much for coming. It's great to see all these folks in the room. I hope everyone's been having a fantastic JNUC. I think I'm finally able to go up a flight of stairs and not be completely out of breath, but we'll see. So, but first things first, let me go ahead and introduce ourselves. My name's Ryne Haley. I'm an engineering manager at Salesforce. My responsibilities are for our client automation team, as well as our client platform Linux teams. Here with me today is one of the engineers on my team.
My name is Carlos. I am a client platform automation engineer. I work alongside Ryne. I usually specialize in helping our automation partners or our endpoint platform teams solve some of their most hardest and complex problems through the practice of automation. So here we are. Let's start with a picture. Who here resonates with a picture on screen by a show of hands? You ever had a work day that's felt like this? Perfect. This is a great segue. You're making it easy for us. We felt this way a lot as well. And this is kind of what's going to really be powering our talk today is how do we work through this dumpster fire and kind of when everything is going wrong, what do you do about that and how can you help yourself get what you need to do to figure out your problems?
As many of you that raised your hands, no, we've all been there in our careers, right? Things are on fire, our users are unhappy, and you start to do triage and incident response, and you find out that the one log you need isn't the one you're shipping to Splunk, or it's just something really weird in the user space, or it's just kind of not what you need at that moment, right? And so we try to go at it a couple different ways, but this only ever seems to happen right at the end of the quarter, or right after that Mac OS update that you tested really, really well, and suddenly one tower halfway across the world that has no on-site tech support, no one can get online, and you don't know why, and it's just kind of a pain, right? So you start engaging with users, right? We run some scripts, grab some logs, but there's always one more thing, right? And it always takes so much time when you're trying to respond to issues in your environment, technical problems, and really around this, identifying what the root cause of different incidents or problems that we're seeing in our environments, right? And so after you're spending all that time splunking logs, gathering data, working with end users, after a while, other things start to pop into your head, right? We start to think about impacts to our SLAs, to other business groups, right? Time to restore. Suddenly my manager cares way too much about what's going on and is asking me a lot of questions because his manager's asking him questions, right?
Ryan's asking me questions.
All right, yeah, I'm asking Carlos questions about why is it broken and what are we gonna do about it? Right, and that's a great question. When we think about incident response or identifying trends and things in our environment, we start to ask ourselves, what can we do just to make this better, right? I think one of the challenging things about managing Macs and devices at scale in the enterprise is that when things go wrong, it always seems like it goes wrong in really weird ways you don't expect, right? And when we do our incident response and start engaging with users and things like that, it takes a lot of time and I think absolutely impacts our ability to get people back online faster. So we worked with our Mac client engineering team and started to kind of think about, what's the most time-consuming part of these processes? We're sitting around trying to figure out, why isn't the Cisco VPN client working in this one specific place? Or why can't anyone in this one tower print, right? And one of the things we kept coming back to was it takes a lot of time when we need to work with our users, right? When we need to get someone to, get some logs to us and things like that. So we tried out a couple things, and I think some of these things are going to be really familiar to folks in this room, right? We thought, okay, well, let's, maybe some self-service workflows to, grab the system diagnose that Apple's asking for, and maybe Canon wants some random CUPS logs for some reason. That's all things that aren't being shipped to Splunk or whatever your SIM is at the time. We looked at attachments in Jamf. Spoiler alert, if we found out really, really fast that your Jamf rep and your Jamf support rep don't want you to put system diagnosis in the Jamf attachment field, right?
Something about 10 gigs in your attachments payload.
Yeah.
Not friendly for them.
I don't think I've ever gotten a call back that fast from SEPI until I was like, hey, can we put this here? There's an attachment field. There's an API endpoint. So that didn't really work out either. That was pretty short-lived. We thought, well, we're smart, right? We can make a really great workflow around this. So we thought, hey, let's combine some scripts. IBM Notifier. I want to shout out IBM Notifier. It's one of our favorite open source tools at Salesforce. We love it and really think it's fantastic to use in our workflows. Mix in some Google Drive, maybe a Google survey to kind of wrap it all into something that our end users could really easily engage with. And that worked for some of our users, but other ones it didn't. And then finally we thought, well, we can always reach out to the users, right? But spoiler alert, like sometimes the users don't want to reach back out to us when it's the end of the quarter and they want to close a deal. They might not care as much about my problem as they do their problems.
Something about $2 million ACV at the end of the quarter. It's something like that.
Salespeople, I don't know, I don't get it, right? So we took a step back and we kind of sat down again with our Mac client engineering team and thought, well, what do we want, right? In a world where maybe we can't buy anything at the moment, if we made a tool, what would that look like, right? And how would we want to use it as basically something to get logs off a device when we want to do it. So we wanted a tool that we could use that was silent if we wanted it to be silent. We could invoke it via a script, right? We're a Jamf shop. We love Jamf. We're going to keep using it. So I need something that I can poke at with a bash or ZHS script. I needed something that had some semblance of secure secret handling, right? I don't want to have credentials being passed through a script parameter or any number of things. I wanted something that had at least some obfuscation that we could work with. I also needed something that supported large file types, right? You've seen system diagnoses recently. They just get bigger and bigger and bigger. And when Apple's asking us for 30 or 40 computers worth of data sets, it gets big fast. So I needed something we could just throw a bunch of data at. And finally, in our environment, it was really important that we didn't have our endpoints directly interacting with our Jamf environment, right? So we wanted to be able to deploy this tool with Jamf, to invoke it with Jamf, but we didn't want the machines to reach back out and talk to Jamf. So, great. We got these requirements from the Mac team. We thought, okay, what can we come up with, right? So now I'm going to go ahead and hand it over to Carlos, who's going to kind of run through our solution. He's going to share with you all the infrastructure and also as well as how you can do this yourself. So, Carlos, take it away.
All right, thanks, Ryne. So we're going to do another poll. We did one earlier at the beginning of the session. Who here is familiar with any of the icons on screen? Show of hands. Awesome. So that means for a lot of you it would be similar ground. For some of you might be some new ground. Well, this is going to essentially be the high-level overview of our architecture. And so obviously here we have the Swift binary, and then we have on the right side, we have a variety of features hosted by AWS. And so we're going to talk about how these work together and how we use them to talk and put together the file upload tool. So let's break it down. So here, our front end is powered by a Swift binary. And so the biggest thing that we want to call out with this Swift binary that powers this front end architecture is it's very easy to set up and it's very performant. And so easy customization was something we really had in mind when we're talking about if you want to use this in your environment. This is a binary that's powered by less than 300 lines of code. A couple of quick swaps of some secrets, a quick build, and you have your Swift binary powering your front end on your Mac client and ready to go. It's as simple as that. So that's what's going to power our front end here. We wanted something small and efficient. I'm sure all of us are always worried about deploying more agents to our systems, right? And so when we talk about not wanting to hinder the user experience, we want something that's not going to increase that launch D or that kernel task to crazy efforts. We want it to be agile and flexible. We want to be invocable via script or a shell, right? A lot of people here are Jamf customers, but this is not something you necessarily have to use Jamf to do. You can power it from any MDM or any remote execution or delivery mechanism. And so it's very customizable and very agile. And then, of course, we all want really good logging. If something goes wrong, we want to know about it. So that's the Swift binary. So let's take a look at what powers the back end. So this is a high-level overview of our architecture. We have our client system here on the left-hand side, and then we have our full data flow. And so we're going to kind of break this up individually and talk about how this works together. So let's start with the very beginning. So first, we have our file upload tool binary. This is our Swift binary that we talked about originally. That's going to be deployed to our macOS endpoint, and that can be delivered via MDM or your tool of your choosing. And so there's a couple key things here that's going to start off our process flow. We're going to have an HTTP request payload. That's going to include some things like our authentication header, our file name, some MIME type information, types of file you're going to be uploading, and, information about the size of the file, so on and so forth. And so that request is going to go to our API gateway, and there we have a pre-signed URL endpoint. And that pre-signed URL endpoint is going to be responsible for some of our initial responsibilities on that initial request that goes through. That pre-signed URL is important because it's going to allow an additional layer of security, right? Because you don't want to have session stealing or having your binary try to upload from a session from another machine. And so having this pre-signed URL mechanism is going to add another layer of abstraction when it comes to uploading to your destination. So we have that pre-signed URL. What happens in that payload? Well, we are essentially an event-driven architecture. So we see here, for those of you that are familiar with Lambda, and by that show of hands, we did have many of you. Before we want that to take action, that endpoint on their pre-signed URL, we want to do some validation. And so that authentication mechanism is going to read the token information from your request, and it's going to go into secrets managers, essentially AWS's version of secrets management, and it's going to do a matchup there. And if you have a valid authentication token, that's going to go ahead and pass, and you're going to be green to go. Now that you have that valid authentication, we're going to go back to our Lambda function. We're going to process our pre-signed URL method, and that's going to give us back the URL we need to do our upload. So we've been authenticated. We know that you're tried and true, and this is a valid request. What we're going to do is we're going to take that pre-signed URL we got back from our Lambda function, and we're going to pass it back to our endpoint that made that original call. And we're going to go ahead and essentially upload the files that we said we passed in that original request to our S3 bucket of your choosing. Now you can imagine, for those of you that are familiar with AWS, this provides you a lot of flexibility as far as restrictions or mechanisms or anything you want to extend in this flow, whether it's maximum file size allowed or types of files or any other workflows that you may want to extend off of this. But essentially, once you have that valid authentication pre-signed URL, we're going to go ahead and take that payload and send it and put it in our S3 bucket. From here, we have one last thing. You send a bunch of bits up, but you want to make sure they got there. So now we have our confirm upload endpoint. And we're going to just go ahead and just validate in our bucket that all the bits got there in one piece. And it is important to call out here is that we don't have a built-in retry mechanism. So it's important that you're validating that your output or your upload was successful and use that verbose logging to make sure everything went well. And if something went wrong, that's your opportunity to look into it. But again, with having the flow set up in this way, you can obviously extend this to include additional retry mechanisms or increase that level of verbosity in your logging at that time. So we've confirmed our upload, and we've seen a little bit of how this backend flow works. You're probably thinking, well, how do I use it? So we're going to take a look at some demos here of exactly how you can use this in your environments and kind of get a feel for how this workflow transitions into real world. So here on screen, we have a shell output. And so the first thing I want to draw your attention to is just the ease of use with this tool. You can see it there at the top. We have a path to our binary, and then we have the path to the file we're uploading. It's very simple. We want this to be something that's easy to use and set up with yourself. And so once we have that set up, we have that call set up, we have some key information. We have our file size, MIME type. We have some logging that tells us that we're going to be generating our pre-signed URL, so on and so forth. And obviously there you have your S3 URL where you're going to be able to find and locate that information that you've been uploading. Again, as Ryan mentioned earlier, this local binary does support large file uploads. And again, you can continue to refine that via any restrictions you want to set up on the back end and use that logging to make sure that everything went smoothly. So this is just a snapshot of a quick upload of a test PNG. Well, let's take a look at how you can use this workflow a little bit with Jamf. So here we have a pretty traditional shell output. We've all run a policy via the event line shell workflow. And here we're just essentially grabbing a sysdiagnose And once that sysdiagnose is done capturing, we're gonna go ahead and use our binary tool to upload to our S3 bucket. But while that sysdiagnose is running, this is an opportunity where we wanna kind of really highlight the opportunity cost of using a tool like this. When you think about if you're troubleshooting a problem, especially a long problem that's spanned more than a couple days or even a few weeks, it's easy if you need to grab logs or information from one system. What do you have to grab it from 50 or 100 or 5,000? You can set up this script to essentially grab your sysdiagnoses, your Zscaler output, your CrowdStrike dumps, and then you can just set this and forget it, and you can go check your Amazon packages at your front door, or go make your coffee, or go help your tier 3 support team. So you're saving really a lot of time, energy, and effort from an OpEx standpoint when it comes to using a tool like this, especially the more you scale it up. It's very easy to just delegate a task for something like grabbing information off of 2 or 3 systems. But again, think about the time savings that you have when you do this for more. Once it's done, our files pull up in our S3 bucket, and then the world is your oyster. You can use it, pull it open, pass it to your vendor, pass it into any other extensible part of this workflow, whether it's ingesting it to another data source or taking action on that file upload. Maybe it's via webhooks, so on and so forth. Let's take a look at another example. So this should look familiar for a lot of you. This is self-service. And this is just a very typical self-service driven workflow. Again, what we're gonna see here is a more UI-focused workflow. And this is, again, powered by IBM Notifier. No shucks there, we do love our IBM notifiers. And so what I want to highlight here is that just the flexibility you have in a workflow like this. Here we're using a progress bar, but what if you want to capture actual manual input from the user? This is your opportunity to maybe extend a text box. Maybe add some radio buttons. Maybe they're dealing with a network issue. You want to know how poor the quality was of that experience. They can click that radio button, and so you can get additional information while this is running in the background. So in this case, we just simply have the user waiting for the upload to finish, whatever pre-exposed logs we wanted to capture, where you can really extend this workflow to do a variety of different things from a user feedback gathering perspective. And again, that upload's done and we end up in our S3 bucket. So now you've seen a couple of examples. Well, then you're curious, well, how do I do this all myself? This is pretty cool. I would love a workflow where I can capture all this information and go and make a coffee or get that extra croissant from your local bakery and save yourself all that time. Well, good news is for you, so we have a plan for that. So here we have a QR code up on screen. There you can see a little bit of the code for the Terraform that we have set up to set up this AWS infrastructure on your own. Get up and running in a jiffy. There you'll also find the Python files for the Lambda function. And from there, you also have the Swift files that allow you to ready and build the Swift binary for your client systems, barring that you swap out those secrets and that infrastructure is provisioned and ready to go. And so now Ryne's actually going to talk us a little bit through what are the other things we should be thinking about when using a tool like this.
Right. Yeah, so I'm going to kind of cover some gotchas, general thoughts and things like this about this tool. So in the slide previous, Carlos mentioned that there is everything that you need to kind of get this together and get this stood up if you want. There's the Swift file that you need to, will take your secrets, your bucket name and whatnot. We've got the Terraform. It seems like infrastructure as code has been a hot item this year at JNUC, and I really love the flexibility of being able to just run a Terraform plan and a Terraform apply and see all of that infrastructure get set up for you in AWS, right? And so with all that, we've provided kind of a working baseline that you can spin this tool up with. And with that, I want to call out that every organization's security posture, requirements, things like that are going to be different, right? So I want to emphasize that what we provided is a baseline, and that can be customized, changed, and modified to kind of do whatever you need to do for your organization and to kind of meet those different requirements, right? One of the things I really love about this workflow and what's been really useful to us is with it being event-driven in AWS, with a Lambda function, you can add additional things to have happen. Maybe you want a webhook to get fired into Slack whenever something gets uploaded so that someone can go take a look. Or maybe you want to have additional actions happen in other tooling and other internal systems. Or maybe you want that to reach back into Jamf and have it do something there as well. So for us, a lot of the beauty and a lot of the efficiencies that we found with these kind of tools and these kind of workflows is being able to easily customize it, right? And I think using Terraform and using different tools like that to stand up and change that infrastructure makes it a lot easier in my opinion. Other things to cover too is, as a Mac admin, and as I've been one now, I think coming on 10, 15 years, is that a lot has changed, right? If you've been a Mac admin for a long time, I think it's safe to say that the required skill set that we need to do our jobs has changed drastically in the past decade, right? I remember when, if you could write a shell script, it felt like you were a wizard. I was like, oh man, this is great. And then now when I check out job postings for client platform engineers or what I'm looking for when we try to hire engineers to our teams, it's a lot different, right? It's a mix of software development, API experience, CI/CD workflows, all these different things that honestly just weren't part of the equation of being a Mac admin, 5, 10 years ago. And so with that change, I really, encourage everyone to take the time to learn new technologies, to experiment with different workflows, to see different ways that we can use our tools and our MDMs and to continue to be marketable engineers in today's world, as well as come up with these really neat workflows, right? Like API first and API everywhere and infrastructure as code isn't going anywhere. And I think tools like this paired with tools like Cursor and Claude and different AI coding tools really lowers the barrier of entry to kind of understand and do this in your own environment. So I really encourage folks, take a look at what we've got posted at that GitHub link. Check it out, change it, modify it, see what works for you, what you don't like, what you do like, right? We've gotten a lot of value out of adding these to our workflows, and I hope that y'all can find some value too. So with that, that is going to transition us into Q&A. And
Great,
yeah.
Thank you. Yeah, if anybody has any questions, just please raise your hand and we'll give you this mic. Anyone initial thoughts?
Don't be intimidating about having to be a DevSec Mac platform security DevOps engineer, okay, guys?
Yeah.
Options other than AWS for, say, storage on that, just because, for instance, other than the Jamf Cloud distribution point, I have zero ability to use AWS.
Yeah, so you could, in that case, right, you could absolutely swap out, there's a block of, there's a function in that Swift code that is just handling that upload. So if, storage with blob storage with Microsoft or Google Cloud or whatnot, you could really swap that out really easily. Outside of that, when we developed this tool, we were focused on AWS because that was the infrastructure we had. So, yeah, I'd say you can restart fresh, go ask your favorite AI tool to build something, and you'd be surprised at what could pop it out. But
I'd also say I would just add to that too, this is a form of getting files to a certain cloud destination, but if you want to rework it to save the information locally, right, you can be a little bit more creative, and let's say you want to involve a little bit of light touch maybe with your level 2 or level 3, you can rework the strategic idea of what you're trying to achieve with the tool, and you can work it to maybe put that information in a certain location and tie it into a different workflow to extend that. So try not to limit it to just AWS or GCP or Azure Blob Store, but think about how you can use it to maybe extend an existing workflow or enhance one you already have.
yeah, because you could totally shove that in like a local SMB share if you wanted to or something like that, depending on how on-prem you are or whatnot. So, yeah.
Are you doing something with the metadata that you're collecting and like something that correlates that to the files being uploaded, or is that like just inherent in the URL that you're giving out? Like, how do you know like what endpoint has which files that you've uploaded, like after the fact when you're reviewing these files?
Could you speak up a little more? Sorry.
Yeah. So like how do you know after you've uploaded all those files through the tool, how do you know which endpoint has which set of files? Like, what's the correlation between like the metadata, like the endpoint that generated those files, and the files themselves? Like, is there any like code in there that you're like creating an interface to make that out of like correlation, or are you just going to the S3 bucket?
We're just going for this, yeah, we're just going to the S3 bucket for this. So
Okay.
having the flexibility, in our current workflows right now, we're usually taking a mix of like a system diagnose, pulling logs out of like Adobe for like Adobe RUM or something like that for updates.
For you Adobe RUM
Yeah.
enjoyers.
Wrapping them all in a zip file and doing that all in Bash. And then the last mile is really calling the binary to say, hey, go ahead and upload this. You absolutely could add, at the point when that pre-signed URL gets handed over, add additional logic there on the AWS side if you wanted to make that cooler. I'd say internally, like, we have added additional automations onto that to kind of make it more useful for us. But totally could.
Yeah, another thing I would add to that too is that S3 obviously does have a lot of feature sets as far as prefixes and optionality there, and so you can trigger additional workflows once that file lands in that bucket if you want to do correlation as far as certain folder structure or take an additional action, do another feature that AWS offers. So you can use formatting in that way as well.
Yeah, folders is a good call out. We did use folders in S3 to break things up based on incident was going on, or if it was specific things, by directing that to help us kind of narrow that down.
Question in the back.
To allow the Swift binary access that API gateway, I guess the API gateway is open to public internet. So I want to know that if that Swift binary authenticate to access the API gateway, and if it does, how is that the access credential is handled?
Is the question how the binary authenticates to the secrets manager in that flow, as how are we validating that you're allowed to do that upload? Was that the question?
Yeah, so when the Swift binary send a request to the API gateway, does it authenticate?
Correct, yeah.
If it does, how does it handle that the credentials on the computer?
Yeah, so essentially we do have a variety of multi-level obfuscation within the binary for some of those secrets that you're doing when you build that binary. What's happening is when we get that request payload from our API gateway, we're going to unpack that and validate if the secrets that are de-obfuscated through the logic that's built into the code, does that match what's in your secret store? And if those things match, you're allowed to do that put request and we'll give you a pre-signed URL back. If you do have a token mismatch there or that doesn't match up what you have here in your secret store, then that's gonna be an invalidated request and the upload will not give you a pre-signed URL back.
One of the challenges that we kind of ran into with these kind of things is that when we're doing incident response, we not always have like a healthy Mac in front of us. So I can't say, okay, well, as long as it has its user cert or its device cert and can, auth against some internal resources, we didn't want to necessarily put a bunch of barriers up in front of that because often they're broken machines and we need to figure out why they're broken. So it is a simple shared secret match, right? And that's what we're putting in front of it with this proof of concept or this kind of baseline that we have here. But we have got other stuff, that is behind cert validation, and that kind of comes back to, adjusting or modifying the what's in AWS and what's in Lambda to match what the needs of your organization are. So.
And it depends on your use case too, right? If you're going to use this to a very niche use case, you could add that additional layer of security where I actually worked on a feature request that I never actually merged in, but essentially we have a ETLS certificate to access our internal network, so access Okta, internal office Wi-Fi, stuff like that. And so I actually built some functionality to validate if that cert has been expired, does it have to create a schema of what we would expect that cert to be, and if you have a match there, that can be an additional check that you can do before that pre-signed URL attempt is even attempted. So there are things that you can do to extend the security mechanism of it even before the initial request goes through. It just depends on what your use case is going to be.
And one other thing I want to call out too is where you can find us, right? So you can find us on the Mac Admin Slack at the channel that's, I think, Mac at Salesforce. Feel free to reach out on LinkedIn as well. We're both on there. There is a messaging feature in the JNUC app as well that you can use to ping us if you have any questions as well. We'll also be here afterwards if anyone wants to chat as well.
What he said.
Awesome. Thank you, guys. Big round of applause to them, please. Thanks again. Everyone's free to kibitz around. You guys are done. Good job.